This conference will now be recorded.
Hi guys, am I audible? Hello, can someone quickly confirm?
Yeah. Hello, yes, you're audible.
Yeah, fine, thank you. Okay, fine. Yeah, guys, how many of you know? Before we start, like, let's have a small introduction. So, how many of you know about data engineering and these things before we go into the concept? Hello?
I mean, exactly what all skills are you asking that if you
No, no,
know?
no, 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 no. Why you are getting to learn data engineering? Do you have any previous idea or anything? So, guys, here, how many are working professionals?
Yes, Rish, I'm from Wipro, but I'm completely new to this data engineering course.
Okay, fine.
Yeah.
Remaining guys, any freshers or everyone is working? Okay. Any freshers over here?
Hello, yes, I'm a fresher.
Okay, fine. So you don't have any experience, right? In IT.
No,
Okay,
yeah.
fine, thank you. Sorry, I'm speaking on mute. Am I audible, right? Hello guys, am I
Yes,
audible?
yes, yes.
Yeah, fine, thank you.
Yeah, we can hear you guys.
Fine, thank you, thank you. So yeah, so something I see here, people are working professionals. I see people are freshers. So let me ask you a first question: what is data? Any guesses? So yeah, let me introduce myself before starting into our concept because it's time. Okay, I am Raj. I have around 12 years of experience in IT. I have worked on different technology stacks. MSBA someone said. Hadoop Big Data and Azure. Okay, getting it right, guys? So coming to my teaching experience, taught more than 50 batches. Okay, okay then. Now let's go into our concept, data engineering. Okay, before going to data engineering, these things, let me ask you a quick question. What is data? Any guesses? Hello? Hello?
Hello. Yeah, it's a collection or a store of information.
Okay, fine. Okay. Any other guesses, guys? Okay. Any other guesses? First one. Okay. Data is collection of raw facts. Collection of raw facts. Okay. Second, let's go to, so first our agenda is what is data, types of data. Okay, and formats of data, what we see in your day-to-day real life. Okay, so first point, data is a collection of raw facts or objects or entities. Okay, data is representation of some aspect of real world. Okay, we can classify this data as structured, unstructured or semi-structured based on how it is organized. So what is information, guys? Now, hello, hello, what is information? Information is basically the processed data by which you obtain some inferences. We call it as information. The processed form of data we call it as information. Okay. Next question. What are types of data you see every day? Can someone any guesses? Hello? I'm audible, right?
Yes,
I
it
guess.
could be any
Yeah.
sort of text, number,
Okay.
date, I mean dates, transactions.
Okay.
We
Not text or nothing. Types of data, classification of data. We see basically three types. One is structured. Second one is unstructured. Third one is semi-structured. Am I correct?
yeah.
So structured is nothing but you
Right.
see in your table format which has definite shape. Am I correct?
Yeah.
Unstructured, which does not follow any shape. Semi-structured, so some extent you have shape, okay, where you can understand the data. Here is a mixture of data. It's an organized data. It is some extent organized data. Am I correct, guys? So information is nothing but the processed data. We call it as information, by which we can gain knowledge, and using information we provide a solution. Coming to, as I said, classifications, types of data: structured data, unstructured data, semi-structured data. So coming to structured data, what we have, guys, we have something called databases. As data is organized, that means predefined data models, easy to search, text-based search, shows what is happening. Coming to semi-structured data, loosely organized. That means there won't be relation completely between the data. And coming to unstructured, as you know, there won't be any relation to the data, complete relation. So semi-structured data examples we have your XML, JSON, email, web pages. Structured data you have audio, video files, image data, natural processing language, and documents. Okay. So these are the different formats. These are the different systems we store your data. Like formats are some tools. Okay. Now, as I said, data represented as rows and columns, also called as relational data. That we call it as structured data. Your databases, that data what you stored in a database, we call it as a structured data. Coming to semi-structured data, data stored in files which have some degree of organizational structure, we call it as semi-structured data. Okay, your JSON files, XML files, and unstructured data that cannot be contained in row column structure and does not have any associated data model schema, that we call it as your unstructured data. Your audio, video files, social media, this we call it as an unstructured data. So what is a database? Any guesses now?
What is
What is a database?
a database is a software which will be organized data into form of tables, and either
Okay,
structured tables or unstructured data or semi-structured data. It could be anything.
okay, okay, okay. Let's see what is database. Database is nothing but collection of structured information or data stored electronically in a computer system. And database usually controlled by a system called database management system. Together data and data DBMS along with associated applications with them. Okay, that we shorten, we call it as a database. That means whatever the structured data we place it in a tool or a storage, we call it as a database, and it is typically electronically stored in a computer, and this is controlled by a software called database management system. Okay, so if you see over here, if you think it as a database, your data, your organized structured data will be placed in a database. Okay, so where you can do some inserts, update, deletes. What is your insert, update, delete? That means you can modify the data, change the data, you can apply some operations on the data as it's in structured format. Okay, now any guesses, guys, what are the popular databases in the market?
Popular databases: Oracle, SQL
Okay,
Server, DB2.
okay,
Those are
Oracle,
the
SQL servers,
traditional
or
databases. Yeah, DB2,
okay, DB2. Any others?
Teradata.
Okay, yeah. So now these are traditional databases. Now next, So here databases are classified into two types. One is SQL and NoSQL. Okay, what are this SQL and NoSQL? SQL is nothing but, as I said, where your data is stored in tabular format. Okay, we call it as a SQL database. Coming to NoSQL, where your data stored either in columnar, okay, JSON, graph, document. We call it as a NoSQL. So any examples for NoSQL, guys? NoSQL
No,
databases? Your MongoDB,
MongoDB. Mhm.
Cosmos from Microsoft. Okay,
Cosmos, yeah.
Cosmos DB or MongoDB, any Cassandra. These are all your NoSQL databases. So we have learned about what is data, information, classification of data, and where we gonna store this data in which type of tools. Okay. Now, so NoSQL and types of databases, SQL and NoSQL. So in NoSQL, your database doesn't have any schema. As I said, definite schema will not be there. What do you mean schema? Schema is nothing but a predefined organization rules. I call it as how to store your data. Okay. Next, anyone heard about a term called big data? What is big data? So before going to this big data and this concept, so we learned data with these things, right? Now, so you got to know about data and these things. So earlier stages, how we used to store the data, guys, without these databases, these things. Hello?
Without, you mean in the tables or without database?
No, without database I'm asking. So without
Files and
databases,
folders.
yeah, files and folders, right? Now, why this big data came? So when you have a database, when you have NoSQL, these things, why this big data came into the picture? Okay. Now, what are the data I am having day to day? So before going to big data, let's go like this, guys. Everyone using mobile phones, right?
Yes.
Am I correct?
Yeah.
So in mobile phones, so how many apps you use, guys, every day? Maybe 10 to 15 regularly. Your Insta, your Snap, your Facebook, your Twitter. Hello.
Yeah.
So let's think like this. So one user 15 apps, 1 MB for one app for 1 hour. Okay. So on an average, how many hours you use, guys? Each application. On an average 1 hour. So one user 15 MB 1 hour. On an average every day 5 hours. So how much amount of data you are consuming by from each application? And these applications will store various formats of data. Am I correct? Some will do your text, some will do your videos, some will do your audios, different kinds of files. Am I correct?
Yeah.
So
Yeah.
all this data what you are getting it every day by each application to their to their end user, like their end organization. Are they able to accommodate with these traditional databases in the format sizes? Because vast user has been become and your application and the data shaping has been vast now. Like earlier we have data in text. Now your audio video files, mixture of PDFs. So how they gonna store? With this thing, people thought of something called big data in the market. Okay, what are the legacy systems or traditional databases you have? Okay, they could not accommodate the data which you are having it. Okay, different file format of data and size of the data. Okay, which traditional databases cannot handle. Let's go. So basically, big data refers to data sets that are too large or complex to dealt with by traditional data processing application software. Okay, data with many fields offer greater statistical power. So what is big data means? Either whatever the system you having. Let's take like I have a jar of 25 liters. Okay, but earlier I have a water flow of 25 liters. My jar accommodating it. Suddenly I have a water flow of 50 liters, but my jar is 25 liters. Can I accommodate it? Hello.
No.
Same way, if you have an application, suddenly you have 100, you have a statistics for 1 year of 100 users. So you have designed your system or your storage capacity for 100 users, but suddenly you got 1 lakh. Are you able to accommodate all the users' data?
No.
So with this disadvantages, people, what are the traditional systems? If I get a data more than what I have, what should I do? Or if the data format or picture I am getting, which is differ from my traditional system, what should I do? With these two concepts, big data was introduced into the market. Okay, so as I said, it's too either it's too large in size or complex to dealt with. Traditional data processing application software. So to classify any data as a big data, we have something called 5 V's. Okay, one is velocity, volume. Volume is nothing but the size of the sheer volume of the data what you are getting it. Veracity, different size of data. Variety, different size of different format of data, either it's structured or unstructured. Veracity, reliability and trust. Whatever data you are getting it should give you some information. You should be in a position to extract some information. Velocity, if you are getting the whatever the speed at which you are getting the data, your system should be in a position to accommodate it. Value, whatever the data you got it finally, as I said, it should be able to provide you some information. Okay, so these are the 5 V's constitute to your big data. Okay, any doubts, guys? So people thought about they needed to have a system when the vast application users has been increased and format of data and mixture of data has been increased. People thought about this. Okay, next.
Raj, your
Yeah.
mic is giving disturbance, lot of disturbance. Its voice is breaking.
Okay.
No, it's totally gone now. We can't hear you.
I'm audible right, guys? Hello? Hello?
No.
I'm audible right, guys?
No.
No, it's very low. It's too low.
Okay. Hold on. I'm audible right, guys? No? I'm audible right, guys?
No,
No,
Hello?
not even
no,
now.
no.
Super, sir. Am I audible right now? Hello?
Yes.
Yeah.
Yeah, am I right? Yeah, I'm audible, right? Okay, fine. Yeah, we are in the big data, right? So as I said, which is too complex or dealt with, large in size. With this 5 V's, big data was came into the market. Now, what happened is like, so what is big data means we have a concept called Hadoop, distributed processing system. That means whenever I have a capacity of some, as I said, 25 liters jar, when I'm getting a more flow, I will also accommodate another jar with it. So that remaining amount of volume which I have, it will be accommodated in a different system. So people has what done is like, thought is like, yeah, this is fine, this is having our solution. But what happened is like the cost and the storage, okay, and the tools which was invented to accomplish data or to work on this data on the legacy systems are okay to work on your on-premise systems but not with your cloud systems. With this concept, people thought about we need a separate team of people who can only work on this data. For that purpose, your data engineering introduced into the market. Okay, a new term. Okay, so earlier also there is data engineering, but with something called MSB or Informatica, ETL with these names. But specifically, people they need some sophisticated data professionals. Okay, who can handle various kind of data, what I am getting it, and who can manage this data, who can refine this data. Okay, with these things, data engineering came into the market. So let's take a small example, guys. Okay, see, before going to that social media stats, WhatsApp handles 60 billion messages. Google processes 40,000 search queries. Average user spends 35 minutes on a Facebook a day. 50 million tweets sent each day. 300 hours of video uploaded to YouTube every minute. If you see the exponential data growth, if you see 0.1 zettabytes in 2005, now by 2025, 163 zettabytes, 36% increase. So now, as I said, let's take a small example. Okay, so you have a room in that you have bookshelf, two bookshelves. One consists of different kinds of books, others also consists of different kinds of books. But what happened? One is in organized form, one is in unorganized. If you want to pick up a book immediately, so which shelf you will be referring to, guys? Either organized or unorganized. Hello, hello,
Uh, organized.
organized, right? So here also, when I having a different kind of data from different applications, okay, who can order this data in a proper order? Who can design a system to handle this data? Who can develop a working system to capture this data? Okay, you guys, data engineer. So why data is important before going to data engineering? Data is useful for decision making, to know customer preferences so that organization can improve business, getting right information for business. By analyzing data, we can optimize our systems. More data, more analysis, more results. Data is effective in improving the business value. What is data engineering? There are too many definitions you can find, but basically in general, you develop and maintain a system that can process the data based on the organization requirement. Okay, that means whatever the data flow, the mixture of data, as a data engineer, you need to segregate it, refine it, and finally make it into an information so that your organization will use for their business needs or by the end customer whom you are working. Okay, getting it right?
Yes.
So, okay, who can use it? So before going to that, let's see about something called ETL. What is ETL, guys? Or ELT?
Extract, transform, load.
So ETL is nothing but, so your front end applications, let's see like this. Okay, so let's think this as your front end applications, either your Facebook, WhatsApp, or something, your Myntra, Flipkart, something. Okay, these are your apps from your mobile. Am I correct? So as a user, you will be using different apps, and you will be sending different kinds of, from Facebook you send your messages, these things. Flipkart you will send some invoices, you are doing some purchases. Okay, okay. Now each application has their own specific set of data in different formats. So as an end user, finally, let's take an example of Flipkart or Amazon. Okay, you have placed an order long back, but if I want to know, you will be providing your address, these things. Okay, right? Few some information. But what, guys? When you place an order from your app, you will get some extra information, right? Like your
Yes.
order ID, product name, and your bill. Am I correct? Hello? Product name. What are its reviews? Who is the seller? So you have just placed an order seeing the product, but at the end, as an end customer, you are receiving a different thing. Am I correct, guys?
Yes.
At the end user, you are getting a different thing. So who is adding this data here? From your application, your organization who is providing the application is extract ETL, extracting the data, getting the information from you, appending the needed information, transformation, doing some modifications, finally loading for you. Once you place and buy a product on your app, loaded, what? Successful with all the details. Am I correct? Delivery details, these things. Am I correct? When it gonna delivered, through which they gonna delivered, these things. Am I correct? So here if you see extracting, getting the data from an end user and finally giving it to an end user. One thing. Okay, and as an organization what they will do. So which customer is interested in buying which products? They need to analyze it, right? So whenever you placed an order, which customer interested in which seller, which products? Okay, so they will again analyze your data. So getting your information from here what you are searching and finally so this we call it as ETL or ELT. Either they'll extract, transform means giving you the information, either they extract, load, then they transform. These are the two approaches followed by your organizations today. So most organizations are following ELT approach now. Instead of transforming this one, get the data, load it, then transform it based on my need. Because I have billions of users here. If you take it Flipkart or your Amazon, okay, if they try to transform the data, each and every user, how many days it will take, guys? If they want to review each purchase, am I correct? Hello?
Yeah, it will take a
Hello?
lot of time.
Lot of time, right? If they try to analyze each and every transaction from one user, so what you will do? They will take seller level data. Seller one, how many products got sold from him? Who are all the customers from which place? Extract, load the data from sellers, all the information, then transform it. Seller wise, area wise, this one. Okay, either ETL or ELT. This is the one approach followed by each. If your data set is small, that means your data is small. Limited users, I can do it one by one. But if I have crores of users, if I go for ETL one by one, it takes lot of time. So they will take a bulk of users, analyze the data, sample the data, and finally. So who is responsible for giving all this and making this? You guys, data engineers. Getting it right? Any doubts? Hello?
No, no, yeah.
Yeah. So as I said, so why do you learn data engineering profile in MN? So let's see this now. We need dedicated professionals in order to handle this large amount of information. A data engineer is an IT worker whose primary job is to prepare the data for analytical or operational users. Software engineers are typically responsible for building data pipelines to bring together information from different source systems. They integrate, consolidate, and clean the data and structure it for the use in analytical applications. The main aim is to make data easily accessible and optimize their organization, big data ecosystem. Coming to your roles and responsibility, as I mentioned, no specific or exact roles because someone will work in this phase, either extracting phase, transforming phase, and loading phase. Okay, no exact roles, but in general, build and develop a data architecture. So, to the TTL process, you need to develop a separate system. Build ETL or ELT as we discussed, getting data from heterogeneous sources, data sources, using various tools and technologies to transform the data into reliable standard formats. And you are developing and maintaining secure systems, maintaining data governance as per the standards. Okay. So whatever data you got it as a data engineer, you need to do either apply ETL or ELT. Okay. And create a structure to handle this data. Next, what are the various roles? Data architects, data engineers, database administrators. Architects are the people who are responsible for designing and maintaining the systems and integrating the systems. As a data engineer, you was typically responsible for developing the system. Okay. Administrators are the people who are responsible for securing the system. Okay. Taking backups, whatever the data system you have. So this is one of the difference between a data scientist and a data engineer. Builds data pipelines to pull the data together. Aids data scientist in integrating and consolidating. Structure the organizes the data. So whatever your data you provide for the organization level or end user, your data scientist will be responsible using this data and predicting doing his predictions. That means their algorithms and their systems to get what will happen in the future for this organization, what happened in past, whatever data you supply, what are the transfer data, they will be using this data. Okay. So coming to job trends, 50% growth guys in the market rather than any technology. So if you see a typical data life cycle, okay, ingest the data, that means getting the data from different sources. Ingestion is nothing but getting it, exploring it. Exploring is nothing but segregating it, prepare and train, making it ready, finally placing it, the transformed data. And from here, as I said, your organization, your reporting, these people will come into the picture. So this is a typical data lifecycle of the Azure data engineer. So you get the data from different sources, use your warehouse or databases to place the data, prepare, model the data and serve it. Finally, reporting. Either your organization needs some reports on this data. As I said, Amazon needs how much sales data on these things. And end user, as an end user, what you need, guys? Your order status or how many orders I did. Getting it right? Any doubts, guys,
Yes.
here? So you got some idea on data engineering, right? And who can learn this data engineering? Good opportunities of freshers, career switch, non-technical as well, and computer science background, guys. Anyone can learn this data engineering. So after completion of this course, what you gain? Experience on SQL, Python, ETL pipelines designing, knowledge on cloud services. Okay. So as I said, now why the data engineering role in much domain? Vast increase of population, vast increase of apps usage, vast mixture of data. And every organization data is very important. To keep it in very simple terms. Okay. Any doubts, guys, in this part? Hello? Before going to the content part. Hello?
No doubts.
Okay. Now, going to your content. So we are learning about Azure data engineering, right? So we'll be learning about Azure. What is Azure and why? What is Azure data engineering? Coming to content. First, prerequisites. One is basics of SQL. Basics of SQL. Second one is Python. Okay. Getting it right? Okay. Okay. These are the prerequisites. Coming to Azure data engineering, what will be learning? We'll be learning on storage accounts. Okay. Second one is Data Factory, Databricks. Okay. Next, Azure Synapse. Okay. These are the high level concepts we're gonna cover. Okay, these are the high level things. In detail, we're gonna cover. Any doubts, guys? Hello?
Yeah, I'm okay.
Okay. So go through the content and let me know. Tomorrow we'll be covering on what is Azure and why Azure, what is cloud computing, these things. Okay. What is cloud computing? What is Azure? These things we're gonna cover. And as I said, what are the tools in the data engineering we're gonna use? Okay. Coming to certification, there's something called DP 203 certification for this, and optional certification is DP 900 Data Fundamentals. Okay. Come on, guys. What do you for your doubts? Hello. Someone asking any related information. Okay, fine. Guys, someone I'm getting when unmuted, I'm getting a sound like you as well. So guys, please check your mic. Who has been unmuting it, please check your mic. Okay. Let Surendra, are you talking? Are you talking, Surendra? Anything?
Yeah, well, what is the plan for this completion of this training? Will it be completed in how many days or how
So,
many?
so
10 days.
it's like around 50 hours. Okay.
60 hours.
Yeah, 50 to 60 hours. Okay.
Okay, yeah, about it's a 5-day
Yeah,
class weekly
yeah,
or
it's fine.
monthly.
Yeah, weekly. Yeah, Monday to Saturday, Monday to Friday.
Okay.
Friday, and class will be 1 hour to 1.5 hour based on the concept. Okay. Initially, it
Okay.
will be like 1 hour. Once we got into the concept, we'll get it 1.5 hour. Okay.
Okay. Yeah, it
Yeah.
runs almost like a 3 months time frame.
Yeah,
Or
basically, yeah, not 3 months, basically 2 months. Two,
2 months. Mhm.
yeah. As this part, as I said, we will learning your interview questions.
Mhm.
We'll be covering your what we call every day. I will giving assignments, tasks. That means.
Mhm.
So what are you saying? Like the all are of real time scenarios?
Okay.
Yeah. Yeah, that's it.
Okay, that's good.
And the project explanation will be covered at the end. Okay. Any doubts, guys? Hello.
No, I don't have anything.
Remaining guys, come on.
Yeah, yeah, Raj. We have another courses, right? Data engineering essentials using SQL, Python, and PySpark. Is it the same thing, or else it's only related to Azure?
No, it's like data essentials. Like it will be covering Azure data engineering here. Okay. So PySpark,
Okay.
Python, those will be part of it. Okay.
Okay. It's completely different. It will be not included in this part, right?
What different?
No, like I'm saying, we have another tool, right? Like data engineering essentials, using SQL, Python, and PySpark. So,
So
is there any relation?
Databricks. That is Databricks basically. In the Databricks, will be covering that PySpark and Python.
Okay, okay, that is Databricks.
Here you
Okay,
will get PySpark and Python. Okay.
okay, okay.
We
Yeah.
think we have to learn Python earlier before you start doing this, like are you going to teach us?
we'll giving the basics what is necessary for data engineering. If you want to learn more, you can learn by yourself. For data
Okay.
engineering, what is needed, we'll be teaching it here.
Okay, that's good. Yeah.
Yeah. So if you have basic before knowledge on Python, it's good.
That's fine.
Any other things, guys? You want to know? Hello?
I'm good.
Okay, fine. Okay then, guys, fine then. Thank you. Okay. Hello? Hello? Okay then, guys. Then let's meet tomorrow. Have a nice day.